These are your instructions. In general, you just need to follow the PowerPoint. Please make sure the sound is turned up on your device so you can hear the narration. Your instructions are in yellow boxes on each slide. If a slide asks for homework, don't forget to send it in via Show My Homework, and if a slide asks for Educate to be completed, don't forget to do it by the date given.
By the end of this lesson, you should be able to draw velocity time graphs and extract information from them using the lines and slopes. You should also be able to determine the acceleration from a velocity time graph. Throughout this lesson, you need to be very careful that you're sure what type of graph you're looking at. The graph shown on this slide is the kind of graph that we've looked at previously. It is a distance time graph. For a starter activity, can you draw this graph and see if you can label it? This is our starter activity. From our last lesson, you should be familiar with the distance time graphs, and you do need to know what the line and the different shapes of line represent. So stop the recording here and have a look, see if you can work out what the 4 different sections of the line are showing you. You should have worked out that a sloped line gives you a steady speed. With the steeper the gradient, the higher the speed. A horizontal line, when the distance is not increasing but the time is, shows you that the object has stopped. And if you have a curve, if it is curved upwards and the slope is increasing, then that means you've got acceleration going on. And if the gradient is decreasing, that means the object is decelerating. Now, the kind of graphs we're going to look at today are velocity time graphs. And I will say again, be very careful that you know which graph you're looking at, because though they look the same, the information contained in them and the meaning of the slopes and the lines is totally different for each type of graph. So, velocity time graphs describe the motion of an object. Time goes on the x-axis as before, but this time velocity goes on the vertical y-axis. Now, there are 2 ways you can be asked to work with this kind of graph. You can be given a graph and you have to extract the information from it and describe the motion of the object. Or you can be given the motion of the object in written form and asked to construct the graph. So you need to be absolutely clear on what each part of the graph is showing. So let's have a look at a velocity time graph. The first thing you want to do is start with some axes. Now, on the x-axis, I've got time in seconds, just as we had in previous graphs. But this time, instead of distance, I've got velocity up the vertical y-axis. So let's have a look at a journey plotted onto this graph. Now, the first part of the journey shows this. Time is increasing along this axis, and velocity is increasing. Now, we know that if an object's velocity is increasing, we know that it is accelerating. The fact that it's a straight line tells us that the acceleration is constant or uniform. Now, the second part of the journey is a horizontal section. Now here, you should look at the graph and you should be able to interpret it as follows. Time is increasing across this axis, but the velocity is no longer increasing. The velocity is constant at 10 meters per second. So now we know that this section of the graph shows a steady velocity. Here in the next part, we have a curved section. Time continues to increase, but the gradient, the slope, is becoming steeper. That tells us that the acceleration is increasing. Here we have another horizontal section, which represents, again, a steady velocity. Time is increasing this way, but the speed stays at 20 meters per second. Notice that the speed or velocity is constant, but it's higher here than it was here. And then finally, we have a downhill slope. Now, the slope and the fact that it's a straight line tells us that it's an acceleration, but this time it's a negative acceleration, what we would call a deceleration. And the fact that it's a straight line tells us that it's a constant or uniform deceleration. And it finishes here at 130 seconds when the speed or velocity is back to 0. So that means at this point, the object is no longer moving. You need to be able to read a graph like this or construct a graph like this given the information. This is the key information from our graph. The gradient tells us the acceleration. The flat sections tell us that it's moving at a steady speed or steady velocity. The steeper the graph is, the greater the acceleration is. An uphill slope tells you its acceleration in that the speed is increasing. A downhill slope is the opposite. The object is slowing down. It is decelerating. And a steepening curve is increasing acceleration, and a flattening curve is decreasing the acceleration. We can use velocity time graphs to calculate acceleration. And this should be clear to us because we've already worked out acceleration using a formula. Acceleration is equal to the change in velocity over the time taken. Well, we know on a velocity time graph, we can find the change in velocity for any part of the journey, and we can read the time of it. So the graph can be used to calculate the acceleration. All you have to do is work out the gradient or the slope of the part of the journey that you're interested in. So let's return to our journey, the one that we've drawn the graph for, and let's see if we can calculate the acceleration for the first part of the journey. So I've reproduced that first bit of the graph here for you. And it's this slope that we want to work the gradient of because that will tell us the acceleration for that part of the journey. So using our formula, we know that acceleration is the change in velocity divided by the time taken. And the way we noted it before was A equals delta V divided by T. So reading from the graph, the change in velocity, now that's equal to the final velocity minus the initial velocity. Well, this is the part of the journey we're interested in. The final velocity is 10 meters per second. The initial velocity is 0. So 10 minus 0. And the time is from here to here, which is 30 seconds. So if we put in our figures, 10 divided by 30 gives us an acceleration of 0.33 meters per second squared. Now let's see if we can work out the acceleration for the final part of our journey. Now again, I've drawn that final part of the journey here for our convenience. Again, acceleration is equal to the change in velocity divided by the time taken. So the change in velocity is delta V, the time is t. Here, the final velocity is 0. The initial velocity is 20 meters per second, and it's this section that we want to work out the gradient of. And the time is read across the x-axis from 110 there to 130, which is 20 seconds. So final velocity 0 minus initial velocity 20 divided by time 20. If you substitute your figures in, that gives you minus 20 over 20. Put that into your calculator, gives you minus 1 meter per second squared. Now the fact that the acceleration is negative is nothing to worry about. That just means it signifies that it's a deceleration. The object is slowing down. And that should be obvious to you from the graph because it starts at 20 meters per second and it ends at 0 meters per second. So it must be slowing down. Now here, I would like you to try and do the opposite process. This time, you've been given the information in written form and you're asked to draw the graph yourself. So a car travels forwards at 25 meters per second for 3 seconds before the driver applies the brakes. The car decelerates steadily for 5 seconds until its velocity becomes 10 meters per second. It's your job to draw the velocity time graph for this. And using the graph, find its acceleration while it's slowing down. Stop the recording here and see if you can do that. Now, throughout this lesson, I've asked you to be very careful. Previously, we've studied distance time graphs. Now we're studying velocity time graphs. The lines and the slopes on the graphs signify different things. To make sure you're absolutely aware of what each graph is showing you, draw this table in your book and use the information from the last lesson to fill in this column and the information from this lesson to fill in this column. By the end of it, you should know what all of the lines on distance time graphs and velocity time graphs are telling you. Your final task for this lesson is to send a picture of your completed table, the one comparing distance time graphs and velocity time graphs, to Mr. Rahman by Friday the 5th of June.